Hi students, this is Mr. Yao. Today we're going to talk about 10.1 and we will learn some basics about stats and probability. Before we get into the actual lesson, since in this unit we're going to do some dice rolling and some card counting, so let's make sure we understand how card works in this unit. Typically in the deck of cards we have 54 cards, but that includes 2 joker, and we don't include these in statistics and probability. So our deck of cards only have 52 cards, 4 different suits, each one has 13 cards, and the suits are hearts and diamonds, which are red, and clubs and spades, which are black. So here they are. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, Jack, Queen, King, and in 4 different suits. Jack, Queen, King, we actually call them face cards because, they literally have faces on there. And then here are the 4 suits. The black one that looks like a heart is a spade, and the red one is actually a heart. The one that looks like a 3-piece leaf, that's clubs, and then we also have the diamond. These are the 4 suits. Now let's get into the actual lesson, starting with vocab. First vocab, outcome. That actually means the same thing as in English. It means the result. So outcome means the results of an activity or experiment. So for example, drawing a heart out of a deck of cards. And the drawing here actually means we're picking it out. We're taking it out. It's not like actually drawing. Next, set. A set of things means a collection of elements, a collection of things. But in math, we call these things, elements. And we use this set bracket to contain all the elements. And I would encourage you to pause right here and start practicing writing these curly braces. And here they are. Write it a few times, make sure you know how to write it instead of doing the squiggly line. And we use capital letters to represent a set. For example, let's say S is the set of all integers from 1 to 7. So we write S equals, then we have these curly braces, the front and the back, and then these are the numbers we put in there. And as you can see, we separate the numbers by comma. Next, sample space. Sample space is the set of all possible outcomes, meaning all the possible results of something, of an experiment that we're doing. So for example, sample space of rolling a die. Well, S right there, and because when we roll a die, we can get 1, 2, 3, 4, 5, 6. So these are all the possible results. We put them in a set, and that is a sample space. Next, subset. Subset means a small set of outcome within a sample space. In other words, because it has this sub, it actually means part of a known set. And we still use set brackets and a capital letter to represent. Sample space, let's say all students in period 1, the sample space is we have Sam, Chuck, Mary, Jane, Beth, Robert, and George. Subset A is defined as students with the letter A in their names. Well, Sam has it, Mary has it, and Jane has it, so we put these 3 in a set and defined as A equals. Next, subset B is defined as students who are female. Well, we do have some typical female names like Mary, Jane, Beth, but yes, Sam could also be a female name, but let's just pretend that our Sam in this sample space is actually a boy. So that means the females would be Mary, Jane, and Beth. That's subset B. Last one, event. A set of outcomes of an experiment or activity. In other words, a subset of a sample space. Some examples, an event could be rolling an even number on a die or getting red balls from a bag. A lot of the time when we calculate probabilities, we're calculating probabilities for different events. Now let's move on. Have a look at an example. Activity is rolling a 20-sided die, and the sample space would mean all the possible results when you roll a 20-sided die. Well, that's basically every single number from 1 to 20. So 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Here they are. Event A. Roll a number less than 10. Well, less than 10, then that means A is 1, 2, 3, 4, 5, 6, 7, 8, 9. These are the ones less than 10. Rolling event B, roll even numbers. So B would be 2, 4, 6, 8, 12, 14, 16, 18, 20. These are the even numbers. Okay, let's move on. Now we have a few more definitions. First one, intersection. Just like on a road intersection, that just basically means a point that both roads go through. So in this case, we need to make sure road A go through it and road B go through it. So intersection basically means and we use this upside down U thing to present. That's the symbol. And intersection means where two or more subsets overlap. So as you can see in the Venn diagram, this is the part that is actually shared by both circles. So that is the intersection. Next, union. Union is actually the opposite of intersection. Union means or. So we say A union B. We use this symbol. Looks like a capital letter U. So A, let's say union B, means I have, A or B or both. It could just be anything that's included in A and B. So this means the combination of every element in both subsets. For a Venn diagram, we have two circles, and everything in there would be inside the union. Next, complement. We use this letter C to represent, but you can kind of see this letter C is smaller than our typical letter because this appears as an exponent. So we say like A then complement, like that. So the complement of a set is the set of all elements not contained in the subset. We read it as the complement of A. So let's say this circle on the right side is actually A. Then we want anything that is not in there, and that is the complement of A, which is everything on the left side of the left circle. Now let's have a look at some examples. We already learned event A will a number less than 10. So A would be 1, 2, 3, 4, 5, 6, 7, 8, 9. B would be 2, 4, 6, 8, 10, 12, 14, 16, 18, and 20. These are the things we already talked about. Next, A intersect. So that means A and B needs to appear in both sets. The Venn diagram also represented on the right side. That would be 2, 4, 6, 8. Next, A or B. This means it could be in A, could be in B, or it could be in both. So I need to write every single number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 14, 16, 18, 20. Now you might be wondering, well, if we actually write everything that's in A and B, well, 2, 4, 6, 8 actually appeared twice. Well, even though they appear twice, we just write them once because we know they just appeared. That's all. Next, A complement. We want all the numbers that is not in A. So these would be starting from 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Anything that is not less than 10. Part D, this actually depends on knowing about part B. We are writing down the number that is not included in that set. So you will see the numbers here, 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 and here, which is also right there because these are the numbers that are not in the circle in the Venn diagram. So 11, 13, 15, 17, 19. Okay, that's example 2. Example 3. Group of students, junior, senior, hamburger, and hot dogs. So let's read. Of the 53 junior, 40 prefer to eat hamburger. So 40 right here. And since 40 and another number makes up 53, that has to be 13. Next, of the 37 seniors, 13 prefer hot dog. So 13 prefer hot dog. A number and 13 makes up 37, so that number would have to be 64. 24. When we add these two numbers together, that's 64. 13 plus 13, that's 26. Add them together, that's 90. Or you can add 53 and 37 together, that also gets you 90, which is the total students. Next, prefer hot dogs. I want to talk about students who prefer hot dogs. The number would be right here. It's all the senior and junior together, so that's the total. Next, junior and hot dog. So we need junior and hot dog, which these two column meets right there at that number, so 13. Next, senior and hot dog. Senior and hot dog, so they meet right there. Senior and hamburger, actually. So we want senior and hamburger. They meet right here, so this number, 24. Next, junior or hamburger. Let's deal with that one at the very end. So Next, senior and hot dog. Senior and hot dog, they meet right here, so 13. Last one, not hamburger, that basically means hot dog. So the number is 26. Now let's have a look at E, junior or hamburger. This means they could be a junior or they could be actually prefer hamburger. So all the junior does 53, but the hamburger, if you count 64, you won't notice we actually counted this 40 twice. So instead of actually counting it twice, we just need the other students who also like hamburger, which who are not senior, which is this 24. So you will get 77. That's one way to do it. Or you can count both, 53 plus 64, then just subtract the one we overcounted because 40 is senior and hamburger. So just subtract that, that can still give you 77. That's example 3. Next, example 4. Total people, the question already said is 100 people. Adults is labeled right here, so that's 60. Child and sugar. So this child is actually the total of the 30 and 10. So we just want child who likes sugar is going to be right here. 10. Next, adult who like chocolate chips. Adult who likes chocolate chips right here, 43. Next one is the tricky one. If we are talking about child or chocolate chips. So we want all the child, that's 40. But in the child, we already counted this chocolate chip. So these are counted, but we still need this extra number because these are not the child and chocolate chips. So 40 plus 43, that's 83. Next, adult or sugar. Same idea. We want the ones who are adult. So that's 60. But in adult, we already counted the sugar, so we need the extra part that's not adult. That's 10, that's 7. Not child. That basically means we're talking about the adults. So that's 60. Not sugar means chocolate chips, which is 30 plus 43. We want all the chocolate chips, so that's 73. And next, not child and chocolate chips. Child and chocolate chips would be 30, so it's not the 30, which means it's 100 total minus the 30, which is the 70. That's example 4. Next, let's talk about probability. Probability is actually the chance of something happening. Like, what is the probability if it rains tomorrow, right? What are the chances of raining tomorrow? So we use P to represent probability, and this A is the event that we actually want to talk about. As for how to calculate it, it's the number of successful outcomes divided by a number of all possible outcomes. So the top one, successful, I actually prefer to call it desired event. Like, for example, we want it to rain tomorrow, let's say. We want to find out if it's going to rain tomorrow, so that's our desired. The bottom, it would be the all. So desired over all. There's some rules with the probability, and let's have a look. First, this is the notation, P, then whatever event is. So for example, P, we are rolling a die, we want to roll a 5. Then we just put that inside the parentheses to present we're trying to find the probability of rolling a 5. Next, the probability actually has a range. Any probability actually is going to be within 0 and 1. It could be 0 and it could be 1. When it is 0, that means something never happened, so it's like a 0% chance of something happening. When it's 1, it means it's always going to happen, so it's like 100%. I'm 100% sure this is going to happen, and that's a 1. So all the probability could be between 0 and 1, including 0 and 1. Now let's do some calculation on probability. You rolled a 6-sided die. What is the sample space? When you roll a 6-sided die, you could possibly get 1, 2, 3, 4, 5, 6. What is the probability that you roll a 3? So P roll a 3, because the event is roll a 3, we put that inside the parentheses. The bottom is all the possible outcomes, which is everything inside the sample space, so 6 of them. The top is roll a 3. Out of these 6, there's only one number that's a 3, so we just put a 1. The probability of rolling a 3 is 1 over 6. Example 6, you pick one card out of the full deck. The probability that it is a heart, so probability of it is a heart. In a full deck of cards that we are working with, we have 52 cards. And if you remember, there are 4 different suits. Each suit has 13 cards, and the heart is a suit, so that's 13 hearts out of 52, which simplifies to be number 4. That's example 6. Example 7. You have a bag full of Jolly Ranchers. There are 5 blue raspberry, 8 cherry, 3 apple, 9 grape, and 7 watermelon. So, probability of pick an apple Jolly Rancher. We need to actually know the total. We need to know how many Jolly Ranchers are in the bag. So that would be 5 plus 8 plus 3 plus 9 plus 7, which is 32. Out of these 32, only 3 of them are apples. So 3 out of 32. That's example 7. Next, example 8. Probability of that. We have talked about all of these sets already, so let's just quickly recap. A and B, 2, 4, 6, 8. And A or B, that would be quite a bit. 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 14, 16, 18, 20. A complement of A, that would be 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. Last one, A or B, the complement of that would be the numbers outside. So 11, 13, 15, 17, 19. Now let's have a look at all the probability. All the possible numbers, there are 20 of them, so the bottom of the fraction is always going to be 20. As for the top, the possible outcomes for this one, there are 4 of them, simplifies to be 1 over 5. Next, for B, there are in total, if you count, 15 numbers in there, so it's got to be 15 out of 20, which is 3 over 4. Next, there are actually 11 numbers inside the set, so 11 over 20. Last one, there are 5 of them, so 5 out of 20, which is 1 over 4. That's example 8. Example 9. Preferred hot dogs. These are the numbers we have dealt with already. So preferred hot dog is 26. Junior and hot dog, junior hot dog, that's 13. Senior and hamburger, that's 24. Junior and hamburger, if you remember, that was the junior, so 53. And you either do add 24 or you can do add 64, then minus the 40 that's repeating, which was 77. Senior and hot dog, that was 13. Not hamburger means all hot dog, so that's 26. Hot dog, which actually is the same number as the first one. And not junior, that basically means senior, which is 37. Let's see the probability. Total number 90, so everything is going to be 90, which simplifies to be 13 over 45 for the first one. Second one is just 13 over 90. Third one is 24 over 90, which simplifies to be 15 on the bottom, 4 on the top. Next, 77 over 90 cannot be simplified. Next, 13 over 90. Part F, 26 over 90. Like I said, is the same as part A, which is the same number, 13 over 45. Next, 37 senior, so 37 over 90. That's example 9. Example 10. We also have dealt with all of these numbers, but let's quickly recap again. Adult, that's 60 right here. Child and sugar, that's 10, this number. Adult and chocolate chip, that's this number, 43. Child or chocolate chip, remember child is 40, then we still need to count the other part of the chocolate chip, so plus 43, which is 83. Adult or sugar, adult is 60, then we still need to count the other part of the sugar, which is right here, that's 10, so 70. Not child basically means adult, we have 60 of them, so 60. Then not sugar basically means all the chocolate chips, so 30 plus 43, 73. Next, child and chocolate chips is the 30, but we want not 30, which is 70. I'll need to calculate all the probability. Total right here, that's 100. So all of them are going to be out of 100. 60 out of 100, 3 over 5. 10 out of 100, 10. 43 out of 100 cannot be simplified. 83 out of 100 cannot be simplified. 70 out of 100, that is 7 over 10. 60 over 100, that's 3 over 5. 73 over 100, that can be simplified. And last one, 70 over 100 is 7 over 10. That's example 10. Last definition, experimental versus theoretical. This is actually quite important because a lot of time when we do experiments, we may not get the result that we thought we would. So for example, when you're flipping a coin, typically you would think, oh, I should actually get 50% of heads and 50% of tails, right? But when you actually do it, for example, you just throw it twice, you may actually both get tails. Then that's not 50%. So that's why we need to compare our experimental and theoretical. Experimental means the actual result after you do the experiment, like it actually happened based on the number you got. Theoretical is before you actually do anything, you kind of want to just make a prediction. So that's expected to happen. Now let's have a look at an example that talks about theoretical and experiment. So you spin the spinner 5 times, which means you have 5 different outcomes, which are right here. So the probability of spin a 5, in this case, the total outcome is 5 since you only did it 5 times. As for the top, spinning a 5, that's 1 and 2. So we got 2 over 5. But if you just look at this shape on the right side, theoretically, when you actually spin a 5, that should actually give you, since there are 8 numbers in total, that's 8 on the bottom, and 5 is only one of them, so it's actually going to be 1 over 8. And you can see there's a pretty big difference between the experimental probability and the theoretical probability. However, if you actually do enough times, then you actually get super close to the theoretical, and that's what we want. That's everything for 10.1. Thank you.